Hello everyone. Today we will see the concept of overflow. So while working with numbers, we work with five data types, which is int, long int, and float and double. But we mainly use int, and long int while doing CP. Float and double we only use when we have the values in decimal point. And int, and long int had some rough ranges, which we can consider while solving any CP problem. So for integer, int data type, the range is minus 10 raised to power 9 to 10 raised to power 9. For long int, it is minus 10 raised to power 12 to 10 raised to power 12. And for long int, it is minus 10 raised to power 18 to 10 raised to power 18. So what is overflow? So when we try to save a value which is not in the range of that data type. So if we try to save value 10 raised to power 10 in an integer variable, so it will overflow. Let's see it by an example. So I'm declaring an integer a, which is value is 10 raised to power 5, int b again 10 raised to power 5, and I'm storing its multiplication in an integer c. Let's see out C and see what is the output. Now the output should be 10 raised to power 10, but if we run this program, the output is definitely not 10 raised to power 10. Why is this? Because we are storing a value which is greater than the maximum, which is not in the range of integer. Instead of this integer, if we use long int everywhere, we get the right value, which is 10 raised to power 10. So how this overflow works? Let's declare an integer mx, and we will use an inbuilt value which defines int max, which is the maximum value which we can store in an integer. If we see out mx, so the value of maximum is 2147 and something, so which is and in the order of 10 raised to power 9. But when we try to add 1 in mx and try to print it, so it shows a negative value. Why is that? Because when we add something in the maximum value of data type, it goes back to the minimum value. So this is a cycle which goes on until we achieve the value. So in int max, when we add 1 in mx, it goes back to the integer minimum value, which is minus 2147, which is again in the order of minus 10 raised to power 9. So this concept is known as overflow. Another thing is that when we declare int a and b as int and c as long int and run this program, this will again overflow, because when we do an operation on any two numbers, the, that gets stored, that is stored in the higher order data type. Means if we are multiplying integer into integer, it will be get stored in an integer only, and then again stored in long int c. So first a into b, this it will be overflow, and the value will be like 141006548, and then it will be stored in c, and it will see out c. But if I do one of a and b as long, we get the correct value, because in this operation a into b, the higher order data type is long, so it will work the operation on long int and then store it in c, which is again long int. So we don't have any problem of overflow here, and we get the value 10 raised to power 10. So there are many problems which defines the constraints in a CP problem. Like if we have to take input n and its range is from 0 to 10 raised to power 9, we can use an integer. If the CP problem defines the constraint for n as 10 raised to power 12, we can use long int, and if it is 10 raised to power 18, we can use long int. So always consider these rough ranges while solving any CP problem. Now we will go to next problem, which is how to avoid this. uh, I would suggest just use long long everywhere, and for that we can use this define function, which will define long long as ll, and whenever we have to declare an integer long long, we will just write ll a, and this will be read by the compiler as long long a. So using this you can easily avoid overflow while solving CP problems. uh, and most of people also do just declare int here, and whenever they use int in the uh, program, it will read it as long long, but I will suggest use ll. And every time if it is an integer or long int or long long int, just use ll, and which will uh, avoid overflow, and you will be able to solve the question. So thank you.